Number 46, we're told to solve the equation. We have 3y squared minus 4y minus 15 equals 0. So notice we've switched now and we're dealing with an equation, which means at the end of all of our work, we should have y equals some number. We're getting a solution. But because this is a quadratic equation, we should actually have two solutions, right? Y equals some number, y equals some number. Now, when you are solving a quadratic equation, you want to make sure it's in standard form, meaning the equation is set equal to 0. If it's not, you have to make it set to 0, meaning take whatever it might be here on the right-hand side and either add or subtract it over so that you can set your equation equal to 0. Here, fortunately, all of our work was done for us, so we can go ahead and jump right in to working with the left-hand side here. We're going to factor, which means we have to ask ourselves those two questions. Is there a GCF? And in this case, I don't think there is, so we can move on to question number 2. How many terms are there? And we see 3 terms, so we are going to be using the scissors method. Let's take our coefficient of the squared term. Let's take our constant. So in this case, 3 and 15. We'll put those two numbers into a t-table and list all of the factors. Well, 3 is pretty straightforward. It's prime. But 15, we have 1 times 15 and 3 times 5. We're going to start with the numbers that are closest together, and here on the 3 side, we only have 1 and 3. But here on the right, 15, we have 2 options. So let's start with 3 and 5. 3 and 5 are closer together on a number line than 1 and 15 are. Let's vertically stack the 1 and the 3, and we'll vertically stack the 3 and the 5. And if this combination doesn't work, we'll go ahead and flip that second set and have 5 and 3. All right, let's see what happens when we cross multiply here. 1 times 5 gives us 5. 3 times 3 gives us 9. Is there some combination using a 9 and a 5 with subtraction that we can get to a negative 4? Yeah, I think we can. If we let the 5 here, this cross product, be positive, the cross product 9 be negative, 5 minus 9 gives us negative 4, and whatever sign we put with this cross product bounces over. Whatever sign we put with the cross product bounces over. We can go ahead and wrap these factors horizontally. We're working with the variable y, so let's pop in a y after each of these first terms. And so what we end up with is 1y minus 3. So y minus 3. Again, we're going to get out of the habit of writing the 1. And 3y plus 5. And don't forget, this was an equation, so this equals 0, right? If you want to check yourself, go ahead and FOIL these two binomials together, and we should get back to what we started with. But now that we've factored the left-hand side of this equation here, we're going to set each of these factors equal to 0 and solve. So we'll have y minus 3 equals 0, and we'll have 3y plus 5 equals 0. Well, this equation here, pretty straightforward. We're going to add 3 to both sides, which gives us y equals positive 3 as a solution. Here on the right, we'll subtract 5 from both sides, which leaves us with 3y equals negative 5. And then we'll divide by 3, so we end up with y equals negative 5/3, our second solution. And again, we talked about at the beginning, because this is a quadratic, we should have 2 solutions. Now, we're claiming that y equals 3 and y equals negative 5/3 are the solutions. How can we verify? Well, if we were to take these solutions, plug them into the original equation that we started with, we should get a true statement. So I'll go ahead and show that just for the y equals 3 here. All right, so we have 3y squared, but in this case we're going to say 3 times 3 squared because we're plugging in this y value, minus 4 times y, but we now know what y is, minus 15 equals 0. And again, this is the check, so I'll kind of section that off. Follow your order of operations, so we have to square this 3 first, so this is really 3 times, and 3 squared is 9. minus 12 minus 15 equals 0. Well, 3 times 9 is 27, minus 12 minus 15 equals 0. Well, 27 minus 12 is 15, and 15 minus 15 is 0. So indeed, we do get 0 equals 0. That is a true statement. And so we just proved that y equals 3 is one of our solutions. You could do the same thing, plugging in negative 5/3 into each of these original y variables to get a true statement as well. But there it is, number 46, y equals 3 and y equals negative 5/3.